Time. For us, time is represented by seconds, minutes, and hours, or as we see it on the clock. It is a non-material substance which creates every moment in this world. Time is not a universal measurement, but can we slow time? Let's take a look at this situation. Two identical babies were part of an experiment, Baby A and Baby B, where Baby A goes into a spaceship that blasts off at 99% speed of light and Baby B was left on Earth. The babies would experience time in various ways. 80 years later, Baby B will be an old man and Baby A would only age 1 day. How is this even possible? According to Einstein, time is relative in the theory of relativity. He discovered that time slows down or speeds up depending on how fast you move relative to something else. This fact has been confirmed experimentally countless times. Fast-moving muons takes longer to decay. Light emitted from a moving source has a lower frequency, and so on. That's why if you travel fast, for instance, time goes slow. Time is relative. In Einstein's theory of relativity, time dilation describes of elapsed time between two events as measured by observers that are either moving relative to each other or differently, depending on their proximity to a gravitational mass. Basically, it states that the faster we go, the more time is affected. The rate which it passes depends entirely on your speed and acceleration at any given moment. But if time is relative as this suggests, it can seem a little contradictory. Suppose we're flying past by each other. From my perspective, it seems that you're moving and time should go slowly for you. But from your perspective, it seems that I'm moving, so time should go slowly for me. It seems crazy that we can both think time is going slower for the other person. Someone's time would be actually slower, right? Well, no. Take a look at this situation. This is number 6, but Jepti is rotated relative to me, that's why he reads it number 9. We may think differently, but it's not a contradiction. It's just that we've rotated the height and width relative to each other. Similarly, when you change your speed, you rotate the direction of time. This is another explanation, but it looks like this. If every passing second I move to the left, then my clock will tick like this. And if every passing second you move to the right, then your clock will tick like this. So when 3 seconds have passed on my clock, I'll measure only 2 seconds having passed for you. And yet 3 seconds have passed on your clock, you'll measure only 2 seconds having passed for me. So we think the other is measuring distance in time as shorter, but it's not a contradiction. It's just how time behaves when it's rotated. It affects not just the passage of time, but also our notions in the same time. No matter how weird it sounds, relativity is a strongly supported theory that is one of the main pillars of modern-day physics. This also proves how exciting our universe really is.